Over time, there have been many different views of the way the solar system works. For most of history, the Ptolemaic view was considered correct. This was the hypothesis of a Greek philosopher and mathematician named Ptolemy. His system consisted of a series of concentric spheres surrounding the Earth, containing the moon, the sun, the planets, and the stars. This theory was widely accepted, and it was also supported by the papacy and the church, whose influence covered all of Europe. In 1543, everything changed when a Polish priest and astronomer named Nicolaus Copernicus published a book called On the Revolutions of Heavenly Spheres. This book revealed that the sun did not in fact go around the Earth, but rather the Earth and the other planets went around the sun. Copernicus did not intend to criticize the Church. He was simply attempting to assist the papacy in reforming the calendar to be more accurate based on astronomy. Yet his work caused a reaction and was a springboard for new theories. One such reaction was that of Tycho Brahe, a Danish astronomer. He rejected the views of Copernicus and suggested that Mercury and Venus revolved around the sun, but everything else revolved around the Earth. Brahe made many observations, and in addition collected a vast amount of data that would later be used by successors to prove a heliocentric solar system. One of these successors was Johannes Kepler, a German astronomer. He gained possession of Brahe's research after his death. Kepler advocated for a Copernican solar system. He was determined to use the data to prove it. His work with Brahe's data led to his theory of a heliocentric system where the planets moved in elliptical orbits. He published his book, The New Astronomy, in 1609 with this theory. The debate raged on for many years after this, though eventually it became accepted that a heliocentric universe with elliptical orbits was correct. Newton and the apple. According to stories, Isaac Newton, an English scientist, was sitting under a tree when an apple fell on his head, and he started thinking about why it fell down. He then went on to discover gravity. Whether the apple part is true or not, Newton certainly was responsible for discovering the law of gravity. In 1687, he published the Mathematical Principles of Natural Philosophy. This helped establish the rules of gravity, as well as some new mathematical ideas. In addition, Newton worked on optics and light. He conducted experiments with prisms and collected data that has continued to be useful. His contributions to the field of science, such as popularizing the scientific method in experiments, still have effects today. Galileo Galilei was an Italian mathematician and natural philosopher. Contrary to popular belief, he did not invent the telescope. However, he was the first to use it to make detailed observations of the skies. He supported the Copernican system of the universe and used math and his observations to popularize it. He found patronage under the Medicis in Florence. In addition, he named the moons of Jupiter after the Medicis in order to gain their support. His views were not supported by all. The Church did not support his views on the Copernican system. Because the Church rejected the Copernican system, Galileo encountered problems. In addition, he had some different interpretations of the Bible. In 1616, the Church formally condemned Copernicism, and Galileo was forbidden to write about it. When he published his dialogue on the two chief world systems in 1632, presenting the other views as slow and correct, the Pope was offended, and Galileo was put on trial. He was condemned and forced to renounce his position. He was kept under house arrest for 9 years until his death. However, his contributions to science were great, and his work very important in shaping discussions in the field long after his death.